All right, guys, this is our last unit, Unit 9. All about circles. So, our last page of notes was page 127. Vocabulary, that's what we did in class today. And now we're on page 129, and we're going to be talking about tangents. Tangents are super fun. Okay, remember, tangents are not that tan guy that you see at a beach. They are actually lines that touch a circle once. So, hopefully your notebook hasn't been glued together by that glue from today. We're on page 127. Our objective is to identify the tangents of a circle. And circles as well. Okay? So recall. I guess there's two L's in recall, right? Recall. Tangent is a line that touches a circle at exactly one point. That point is called the point of tangency. Zoom in a little bit, right? Okay. So, if I have a circle, okay, the center H, radius RP, a tangent might be like HP, RP. So RP is the tangent to circle H. Okay, and point P is the point of tangency, and we also know that the radius HP is perpendicular to the line RP. Cool fact, for every point on the circle, there's only one line that is tangent to that point. Okay? So, there's two types of tangents. So we can draw tangents between two circles that are tangent to two different circles. Okay? These are called common tangents. They touch two circles. Okay? So the first type of common tangent is an internal tangent. Okay? They're internal if they intersect the line segment joining the two centers of a circle. So if I were to imagine, I've got these two circles right here, and if I were to draw a dotted line between them, that's the line that's connecting those two circles. And an internal tangent internal tangents would look like this. Both of these are internal. Okay? External tangents do not intersect the line between the centers. So that might look like these. So if I have two circles whose centers are not the same, there's actually 4 tangents I can draw. 1, 2, 3, 4. 2 internal and 2 external. Okay? But the circles can be positioned differently. The circles could be overlapping. In which case, that's a terrible circle. In which case there's only 2 tangents. The circles could actually be tangent to each other. In which case there are 3 tangents. Yeah, that's a terrible tangent. Okay, 3 tangents. 2 are external, 1 is internal. Okay, here these are both external tangents because they don't intersect the line between the centers. Okay, and we could also have the circles be contained, one be contained within the other, but not concentric. So let's say I had one circle right here, then another circle. Okay, here there's actually only 1 tangent, and it's external, because it doesn't intersect the line that touches, or the line segment that connects the 2 centers. Okay, so those are the 4 ways 2 circles could have some tangents. Okay, so again, this one is 2 external. This one is 3 tangents, 2 are external, 1 is internal. And here it's 1 tangent and it's external. Okay? All right, a little bit more about tangents here. Billy, if you're done or if you're stuck, state the M and the B. Okay? So, tangents can come up with some interesting algebra as well. Okay, and we're going to be talking a lot about right angles here. So there are some rules for tangents. Rule number 1. A line is tangent to a circle
Mike Decker, please report to A100. Mike Decker.
if and only if
A100. Thank you.
it makes a right angle with the radius at the point of tangency. Okay. So let's say I had this problem. Well, I have lots of problems, but I'm going to talk about this problem in particular. Okay, I've got 4 points. I'm going to say AB is tangent to circle C at A. AB equals 8 and AC equals 6. So what I already know is that this is a right angle because AB is tangent to the circle at A. If AC is 6, that's a radius. So they're going to want me to find DB, which is just this length right here. Well, I could use the Pythagorean theorem and find the whole length CB, so I'll call this Y. So 6 and 8 are my legs. So I have 36 plus 64 equals y squared. So 100 is y squared. So the square root of 100 is 10, so y is 10. So I know the whole length is 10, but they only want me to find d to b. So I have to use this other fact that I know about circles, and that all radii are the same. So CD must be 6, which makes it so that x has to be 6 plus x equals 10, right? So x has to be whatever 6 I need to add on to get to 10. So 6 plus x equals 10. So x must be 4. So db equals 4. Okay, so that's one way I can use tangents in algebra. The second way, and this is the second rule, is that tangents from a common external point are congruent. And what that means is if I have a circle and I were to draw 2 tangents from that circle to an external point, okay, then DB and EB would be equal. And I can use that to do problems like this, where 2x plus 3 is DB, and maybe EB is 25, and they want to know what is the value of x. Well, since I know that tangents that meet at an external point are congruent, I know that 2x plus 3 equals 25. So 2x is 22 and x is 11. So I could also use tangents this way. So using these two facts, that a tangent is perpendicular to the radius and that tangents that meet at an external point are congruent, I could do something like this. So these are the two rules we kind of follow with tangents.